Here in 4.8, we have the idea of a logical operator, and this starts on page 184. And really, we have three of them. We have the and, the or, and the not. So we can see here on table 4-6 the three of those, and I'll explain here how these work, and then I will have you go to the code samples at the end of the chapter to actually see them running. So our first operator is the and operator. So that is two ampersands, boom, boom, right next to each other. I know here in the text, it's easy to read a space in between those two ampersands where one does not exist. The same goes with the bars for the or operator. That is no spaces in between those. So I know that that trips up a fraction of you, about 25-30%, just depends on the version of the text that you get. It's hard to see. So it's ampersand, ampersand, it's bar, bar. There is no space in between those. So a logical operator, the and, the or, and the not, these allow us to connect two other conditional operators together. So if I'm looking for temperatures that are greater than 0 and less than 100, that's why I would have this logical operator. So each of these has a set of rules that makes them a little bit different from one another, and it's worth noting here. So the first, our and operator, the entire condition evaluates as true only when both the left and the right hand side of the and are true. So all of the statement needs to be true for the whole statement to be evaluated as true. So today it's a San Diego-esque 72 degrees outside. It's a little cloudy, but it's 72 degrees. Is 72 degrees above 0? Yes, that part is true. Is 72 degrees below 100 degrees? Yes, that is true. So we're in the middle of that range, and so that whole expression evaluates as true. What happens if we have a temperature of like 101 degrees? So is 101 degrees greater than 0? Yes. So far the statement is true. The next piece is evaluated. Is 101 degrees less than 100 degrees? No, mathematically that's not correct. So the entire statement is false. So all the pieces have to be true in an and statement in order for the statement to be true. That's not necessarily the case with the or statement. In an or statement, one side or the other has to be true in order for the whole statement to be true. So with the 101 degree temperature range, is 101 degrees above 0? Yes. So far the statement is true. Is 101 degrees less than 100? No. But because the left-hand side of that operation is true, the whole statement is true. So you can see where the or is not good to find, or it's not a good logical operator to use in order to find a range or something inside of a range of values. That we would use the and operator for. The or operator, we're just checking for a partial truth, essentially, for something to be the whole truth there. So, is it above 72 degrees or below 115 degrees? Sure. So the whole statement there can be true. The not operator allows you to take the truth of something and flip it around. So it makes a true expression false. So where would we use a not operation? So we could use not for a flag, for example. So if our flag from the previous example in 4.7 was for special rate. We could send a message to everybody who does not qualify for a special rate that, here's the financing options that you would see. If we are looking for everybody enrolled at Rock Valley College who is not in CIS, that would give us a way to test for a range of values. So that value would be CIS as your major, and we could send really easily to every other major who's not CIS. So that flip of the logic really makes it easy for you, because otherwise, we have many. There's more than a dozen different degree programs that you might be enrolled in at Rock Valley, and it would take us a long time to say in phlebotomy or nursing or engineering and we would have to keep going. Instead, we could just say not CIS, and the logic is a lot smaller for that. Now, there's one more note I do want to leave you here when we're talking about logical operators, and that's all the way towards the bottom of this section, and that is about precedence and associativity, and that's on page 191. The not operator takes precedence over a wide range of the other logical operators here in C++, because what we're doing is we're saying the most important thing in this statement is the not component. So be aware that it is the not expression has some primacy here in not just C++, but all things computer science, because what it allows us to do is essentially turn upside down an otherwise large block of logic and make it much simpler. I'm just going to point you via concept, and you guys can go look it up if you would care to. Some of the fastest types of SSD storage we have are what are called NAND storage, not and. And the reason those are so quick is because that not at the beginning of the logic for it makes those decisions happen faster because of its associativity, because of its precedence way up there in the logical chain. So our three, I'll go back up here to the top, our three logical operators here, and two ampersands or two bars, not the exclamation point.